Hello everyone, welcome to the class once again. It's been a while. I hope you're all doing fine. Okay, and how has been our coding journey so far? I'd like to see your comments. Okay, all right. So, my sincere apologies. This lesson video to have been dropped last week, but amidst my busy schedule, my WhatsApp they malfunction, so I'm so sorry for that. I'll get it fixed as soon as possible. Okay. So this week we'll be focusing on functions. In today's lesson we'll be focusing on functions and data structures. Functions and data structures. Okay. So let's jump right into it. Alright, so what's a function? So a function is just a reusable piece of code that performs a specific task, right? It's just a little bit of code, like some part of your code, which you can reuse at any point, at any given moment, right? It's just, you can just call it a slice of bread, right? You can call it a slice of bread. So it's like a part of your code that you can reuse anywhere. Now, and we have in Python we have built-in functions, which are functions that came pre-installed with Python, and then you can create your own functions too, which you can use either in that particular file or in another file. We'll see later on. We'll see as time goes on into this class. So these are some of the examples of the built-in Python functions. The one that came pre-installed with Python: print. I'm sure you are familiar with that, print. Then we have input, and there's round, and there's random. So these are all examples of built-in Python functions. So how do we get started with our own function? How do we create our own function? You use the def keyword, this keyword called def, right? It's short for define. So def, then you put then space before you write your function name. Let's say I call it my function. This my function is just, I'm just using it as the name of the function. Then you put parentheses like this bracket, parentheses. It is very important. This is how you write functions. Okay, so then you may want to ask that what goes next after this. Well, what goes after this definition or defining your function is the code for that function, right? Remember that function is a piece of code that is reusable, right? So we want to write our code inside it. Now, functions can do majorly two things depending on how we define it. Depending on the code we write for it, we can create functions that can perform a particular task, like say print something, right? Then we can have functions that does not print anything, does not perform a task, but actually returns a value, and maybe like stores the value. So let's get started. Let's create a function called greet. Remember, this is how you put it: def keyword space the name of the function, then parentheses, then you don't forget your colon. Okay, then you write your code under. So what do we want this function to do? We want it to just print what? Print hi. Is a greeting function. We want it to print hi. Now if I run this right now, you would think it will do something, but it won't actually do anything, and I'll explain why. it won't do anything. Why? Because we have just created the function, we have not called it. Now we have light bulbs. You may have light bulb in your house, but I hope you know that if you don't put on the light bulb, if you don't press what we call switch, it won't come on, right? So if you have a gun, if you don't pull the trigger, it won't shoot, right? So functions have triggers also, they have switches, they have what we use to make them to come on, what we used to call them to action, right? And that's called calling a function or invoking a function. And how do we do that? Very simple. You come outside of the code, outside of the function. You don't call a function inside the function, you come outside of it, and maybe you put this double space, this double line like this, just to make your code clean. It's not as if it's going to raise an error if you write it, if you call it here, but just to make your code clean. So you put these two lines, then you call your function. How do you now call it? Just write the name of the function and you put parentheses, and there you have it. Let's run it. So you see now it says hi. It has done what we asked it to do, right? So that is a function that performs a task. Okay, now we can also have functions that returns a value. We can have functions that return a value. Now, just before we proceed, let me bring your attention to something right now. If I say, now remember that we talked about identifier earlier before. Now, what's an identifier? An identifier is what you use to name, is a name given to variables, functions, and many other things. Like these functions actually too. This is an identifier. The name of the function is an identifier. And remember the naming conventions for variables, the rules. Remember that in a variable name, you cannot start with a number, right? Just like in a function, you see it's red, you can't start with a number. So don't forget, all those rules apply for it. You can revise those rules again to know them. So now I don't want to, I'm not greeting this time around. I want to create a function that can add two numbers. Now I say add name of the function, then I put parentheses, and I put this. Now because I want this function to add, I may want to take input. I may want to take input in the form of numbers. So this input, I can write it somewhere here like this: num1, num2. Now these two, this num1 and num2 that I put here, they are known as arguments. They are just like how do we call it? They are just like the input that you pass into this function in order for it to operate. They are required. Now, as you have created it like this, they are required for the function to operate. So let's say I just asked you, remember that I was saying that there are functions that return values, right? Oh, okay. But let's say we want it to just show us the results of this num1 and num2. We can say print what num1 plus what plus num2. Remember that we are going to call the function. How do we do that? Add what? Now if I just say add and I put parentheses, let's see what's going to happen right now. What's going to happen? We have an error. It says missing two required positional arguments, num1 and num2. That is because while I was creating the function, I included these arguments, meaning that they must always be there. They are required. They are the minimum requirements for this function to function, right? So what if I put just one? You see, it will still raise an error, right? Missing one required positional argument. So what if I now add a second number? It will run just fine. You see, it prints the results 5, right? So it gave us 5, which we wanted to do. We wanted to add. Okay, so that's that about that. But now I said there are functions that returns value. You can make this function to return value. Now how do you do that, and what does that mean? You write return and write what you want it to return. What do you want it to return? We want it to return the sum of num1 and num2. Return num1 plus num2. Now what does this mean actually? What this means is that this function will add these two numbers, then it will keep these values. It will take these values and keep it, so you can reuse it anywhere. So if you come outside of this code and you say sum equals to add, now I'm guessing you should know what I'm doing here. What I'm doing here is I'm calling this function, but while calling it, I'm calling it using this variable sum, meaning that whatever the return value of this function is, it is going to be assigned to this variable. So add, remember that I'll put two values, let's say 4 and 5, and I'll say print sum, meaning that it will print the sum. Now print sum. So if I run this, you get the 9, which is what we're supposed to get, right? That's what we're supposed to get. That is what we are supposed to get. Okay. Now, assuming that you want to define a function where you don't know how many numbers will be added, you can just use these numbers here. Now what this does is that it means that you can put as many numbers you want here. So if I say plus num3 plus num4, sorry, return, I can see return numbers. So let's say I want to say sum equals add 2, 3, 4, 5. Now what this is going to do is that it will return all this. Let's run it. Let's print sum. Sorry, that was goof. So remember, you can use your function to do quite a number of things, right? A number of different things you can do with your functions. You can use your function to find the score of a number. You can use it. You can even combine functions with loops. You can combine functions with conditionals. So we're going to jump right into the second aspect, which is data structures. And the first now, earlier we've talked about data structures. Actually, we mentioned it in our introductory class the other time, that data structures are just the way data is stored, right? Data structure is just the way data is stored. Now we have data type in Python, right, which are string, integers, booleans, and so on. But now data structures are just like the advanced data types, right? And we have list, we have what's going on? We have list, we have set, we have dictionary, and we have tuple, right? So these are the four basic data structures in Python. So let's get started with list. Now, as the name implies, list is just a list of data, a list of data. So this is how you define a list in Python. This is how you create a list. You can just put the name of the list. Let's say I say my list. This is the name of the list. My list equals, now this square bracket is used to declare list, right? So anytime you have this square bracket, it's indicating that it is what? It is a list. Alright, now a list is actually an ordered collection of items. What do I mean by that? Each of the items inside it are ordered. They have a specific order. They have an arrangement, right? So I can say 1, 2, 3, 4, 5. Are we following? Alright, my list, okay, equals this. Now, all these, like I say, they are ordered, right? They have a specific arrangement. Now, there's what called index. Index. Now, the index is just the location of each of these values, right? Now, indexes actually start from 0. This one, we have the index of 0. This one we have the index of 0. While these two we have the index of 1, then this we have the index of 2, and this we have the index of 3, and this we have the index of 4, right? So that is how indexing works. It starts from 0 and goes up like that. Now, let me note this to you that list can contain any type of data. Like for instance, we used numbers the other time. I can put a string A, B, remember that you have to put string inside quotes, car, so it can contain strings, and it can even contain boolean. Sorry. It can contain boolean. It can contain boolean. So it can contain any data type. It can contain any data type. Okay. So I talked about index the other time, right? If I say 1, 2, 3, 4, 5. Now I said this one has the index of 0. We usually start from 0. 0, 1, 2, 3, 4. If I want to now first before we proceed, if you print this list, if you print my list, you know the name is my list, it's going to give us exactly how it looks here. This is how it's going to print it out, plain like that, plainly like that. So there you have it. It's going to print it like that. So now if you want to access any particular element, if you want to access any particular item in this list, any of the items there, you use the index. Remember I explained what an index is just now. So this index, this place has the index of 0, this one has the index of 0, this has the index of 1. So this, guess what this we have? This will have the index of 2. So if I want to print, if I want to access this 3, I will use 2 as the index. So I'll put So I'll put a square bracket like this, and then I'll put the index 2. Now guess what is going to print? Guess what this is going to give us? Yeah, 3, because remember I said the index starts from 0, so this is 0, 1, 2. The index is just a way of giving them identity. I say like ID numbers. So this has the ID of 0, 1, 2. That's just my own way of explaining it. So you know this 5 here will be 4, right? Good. Now there's all called list slicing. Now what do I mean by that? What do I mean by that? Let's say you want to just cut a part of this list and print it for us. Now you can do that using list slicing. You can do it for strings actually too. List slicing. So how do you do that? You just say print, okay, my list as usual, but then you put this here. Now that we have this like this, we need to know where we want to start, because it's a portion. Now slicing is just cutting a portion of it, just like you slice onion, you slice bread. It's like cutting a portion of this list, right? So if you want to cut it, you need to know where to start and where to end. Let's say I want to take just these 3. What's the index of these 3? Is 0, 1, 2. That's 2, right? 3, 4. So I will specify the start and end. The start will be this index of this 3, which is what? 2. That's 2. Then the end is 4, right? The index of this 5 is 4. I'll just enter 4. No, not like this. I'll enter it like this. Column. I'll use column. So guess what this is going to do? It's going to print this 3, 4, 5 for me. It's going to print it 3, 4, 5. Let's run it. Oh, wait. So this 2 specifies the start, and this 4 specifies the end. Now what it's going to do is that it will start at this index 2, but then this 4, this index 4, it will stop just before this index 4, meaning that it will start here and end here. Why? Because it will not include this last one here, right? It will not include this last one, because you asked this to stop at 4, meaning that from this 2 to just before 4. Are you getting it? I hope you're getting it. So that is just how the slicing works. That is how it works. And you can even skip. You can skip steps. You can say, now what this means is that start from, let me even start from the beginning. Start from the beginning, which is 0, and then you end at just before the index of 4, 0, 1, 2, 3, meaning that it will stop here, but then it will be hopping 2 times, right? Now you see what it will do. Yes, see what it did? It just took this, upped, and took this again, because we asked it to be jumping 2 steps. You can use 3 steps depending on what you want to do. Okay, now what if you ask it to start from -1 and end at -3? Now just watch what's going to happen right now. Okay, sorry for that. I think that works with strings, not with list. That works in strings, not in list. Now there are quite a number of methods we can use on lists. There are quite a number of methods we can use on lists. There are quite a number of operations we can do with lists. Okay, now we can add an element. We can add an element at the back of a list using what we call append. Now if I want, let's say, to put number 6 that is missing here, I can just say my list dot append. Remember, I must put these parentheses, append, then I will put what I want to append, what I want to add. 6. Now what it's going to do is that it will put this 6 at the back of this, making it to be 1 2 3 4 5 6. Now let me now print the list and see if it has done that. Let me print my list. Sorry. Okay. Right. So now you see it has added the 6 at the back, just the back of it. Okay. So now let's assume that you want to put the you want to add something, but you don't want it to come to the end. You want it to come to the beginning or anywhere. Now if you want to add anything anywhere, you have to use insert. You have to use insert. Let's say I want to put 0 and I want it to be at the beginning. This is what I'm going to do. My list dot insert. Now inside this parenthesis, what I will do is I will first specify the location I want to put it. The location is 0. That's the index 0, right? Meaning the beginning. Then I want to put 0 there. Now what it's going to do is it will take this 0, this second one, and put it at the beginning. This is the position where you want to put it, and this is the value you want to put there. So if I print it now, you see what we get. So it has added it. Just for you to understand more, let me use something else. Let's say I'm writing A, B, then I forgot to put C. Okay, I forgot to put C because you know that if we run this, it will print the A, B, D just like the way it is there, right? But now if I want to, what if I want to add C in this place? Now I need to first know what location it's going to be. Now this is 0, this is 1. I want it to be in the location of 2, meaning that it will replace this one. D will now move back, so meaning I want it to be in the index 2. So I say my list dot, I'm not going to use append because append will just put the C at the back here, and that's not what we want. My list dot insert, then I put the location, which is what's the location? This is 0 1, then 2, right? That's the index. The index is 2. Then what do I want to put? I want to put C, just like this. So if I now print my list, you see what we get now. So we have A, B, C, D, as this should be. All right. I hope you got that. So now the next that we're going to talk about is remove. No, let's talk about pop first. Pop. Now what does pop do? Pop will just remove the last element, just like append adds the element to the last to the end, right? Pop also removes the last element. If I say my list dot pop, but you don't even need to tell it what to pop. Once you say my list dot pop, once you say my list dot pop, it will remove the last element. So let's run this. You see that this is our list, right? A, B, and D. So once we remove the last element, let's see what's next. What's left? So we have just A, B. That's removed this. But let's say you don't want it to remove the last element. You can specify what you want it to remove. Now if you want to specify that, you have to specify the location of what you want to remove. Let's say we want to remove just this B, and the location, the index is what is 1. So Let's run it. So you see AD. So once you specify the location or the index of where you want what you want to remove, it will just remove it, and that's what you get. Now there's another method for removing, which is remove itself. Now what does that do? My list dot remove. Now let's say you don't know the location of what you want to remove, but you know what you want to remove. Let's say I want to remove D. I want to remove D. I want to remove D. Okay. So I'll just say D, and then it will remove whatever whenever D is. Wherever D is. Yeah, that's it. That's it. Now let me quickly show you something about this one. Now if I have two D's, or let's say if I have D here, then I have, let's say the beginning also here is D. Okay. Now this, if I remove this D, it will only remove this first one and leave the remaining. So let's run it. So you see, it removes just the first one and left the remaining. So that's just how that remove works. That's how it works. Now the last thing I'm going to talk about here is sort. Now you can arrange your list. Let's say it's not properly arranged. Now look at this now. D, A, B, D. That's not the way to arrange it. So let's arrange it. If you want to arrange it, use dot sort, my list dot sort, and then you put this parenthesis there. You don't have to put anything here. So if you print it, it would have arranged it. So there we go, A, B, D, D. It arranges it. So no matter how many elements is there, no matter how many items, it will arrange it. Even if it's numbers, it will arrange it as it should be arranged. Now let's say I want to quickly show you how we can iterate through a list. Let's say I have animals, a list of animals. So animals equals to, let's say, cat, dog, goat. Now let's say I want to iterate through this. I can just use an iterator. Remember what we mean by iterating through, right? We use loops to iterate, right? We use loops. I can say for animal in animals, you can just say print animal. So this animal is the iterator. Is what this animal will just, what it will do is that it will pick each of them one by one and print them. So if I run this, see what we have: cat, dog, goat. So I can even say for animals in animal, I can say print animal. I can concatenate it with is, because all of them are domestic. Let's say it's a domestic animal. So let's run this and see. So you see, cat is a domestic animal, dog is a domestic animal, goat is a domestic animal. Just wanted you to quickly see that. So then that is all we'll discuss about list today. Let's quickly move to tuples. tuples. Now tuples are also ordered collection of items, but they are immutable. Remember that when we define list, we could change them, we could remove something, add something. That is not so with tuples. Once it is declared, it cannot be changed. And this is the structure of a tuple. My tuple equals, use parentheses, your normal bracket. Okay, 1 2 3 4 5. You try to say my tuple dot sort, there's nothing like that. It can't do it. It can't do it. It can't do it, right? But you can access the locations of this. Remember that each of these have index. This is 0 1 2 3 and so on. So you can say print my tuple, and you put the location, let's say 0, meaning that the one at the index 0, you know that will be 1, right? So if we run it, you should get 1. Yes, 1 as an output. We got 1. So that is all we are going to talk about in tuples. Now, also tuples can also have different data types, right? Just like list. So you can put strings in it, and you can put numbers, right? Just like in list, you can also combine strings and letters into strings and then numbers into lists, just like that. So now let's talk about the third one, which is dictionary. Now a dictionary is just a collection of dictionaries actually come in pairs. Dictionary is a pair kind of data structure. What do I mean by that? It comes as key and value. Now let's say I define my dict, mean short for my dictionary, equals, now use these curly brackets to define dictionaries. My dict equals, now you have to put key and value. What if I just say 1 2 3 4 5? I think this should work fine, right? So print my dict. It's working fine, but this is not a correct dictionary in Python. In Python, dictionaries usually come in pairs. So the correct way to define this would have been saying maybe A1, you will understand this shortly. B2. Now what do I mean by this? Now remember I said dictionary comes in pairs, key and value. So this first one is the key. After the colon you put the value, meaning that this A has the value of 1, this B has the value of 2. Now if you print a particular key, you're going to get the value, right? If you print a key, let's say I print my dict A. Now A has the value of 1, so if I print it, if I run it, I'll get 1. So that's how you access dictionaries. If you want to print a particular value, you enter the key. You enter the key of it. Now what are some operations we can do on dictionaries? Now there's what we call get, right? There's what we call get. Now what get does is to take if you give it a key, it will return the value for you. So if I say my dict dot get, I want to print it, right? I want to print it. If I say print my dict dot get, so if I enter a particular value for it, a particular key, let's say A. Let's see what the get says. The built-in function method object is not subscriptable. Oh, I think I saw my mistake. Okay, that was the mistake. It was not supposed to be a it was not supposed to be a square bracket. So if you want to get a particular value, you just enter the key and then you get it. If it is B, I enter there, for instance. If it is B, I enter there, it gives me 2. So the next thing we would mention here is keys. If I say my dict.keys, what's it going to do? Somebody guess. Now what this is going to do is that it will return the list of all the keys here for me, meaning that I want all the keys here, so it will return the list of all the keys for me. So A, B, these are the keys, right? Okay, then what if I say my dict dot values? That should return all the values in this place, so 1 and 2. And 2. Then I can ask for items. My dict dot items. My dict dot items. My dict dot items. Okay. My dict dot items. That is going to return this pair for me, A1, B2, like this, or it will be separate. So let's run this and see what it gives us. See, there we have it. It returns it separately. The key and its value, the key and its value here. Okay. Now I can also use update. If I say my dict dot update, now this update is just used to update the dictionary, as the name implies, just to update. Let's say I want to add something to it. Let's say I want to add C also to it. C and its key is a 3. If I print it now, if I print my dict, you see that it would have been updated. Okay, so now C and 3 is added to it. So that does it for today's class. So we have come to the end of today's class. We have learned functions, and then we have learned the data structures. Now I will not be giving any assignment for this week, but I wouldn't want you to just take the lesson for granted. Try to practice with all these things you learned. Look for challenges that you can solve with them, like I would always say. So anticipate the lesson video for this week. This is for last week, so the one for this week will definitely be dropped before the end of the week, towards the tail end of the week, so it will be dropped. Then what I would say, I still wish to remind us that this absolute commitment is necessary, because there will be a certificate for each participant at the end of this course. But in order to qualify for the certificate, you must be in attendance for at least 70% of the live sessions. 70% of the live sessions, so you must be in attendance. Then for the assignments submission, the weekly assignments, I'm scraping that off, because there will be a group project at the end of the this program. So that will be the part of the criteria for getting the certificate. So prepare your mind ahead. We have I think just 1 week ahead of us, right? Because the next coming, according to our syllabus, we have just 1 more week before the project week. So that will be next week. So I won't be dropping the lesson video this week. I'll be dropping it next week. So in the meantime, enjoy, write your codes, debug, and happy coding. So I'll see you in the live session for this week. Thank you.